Okay, so now I was just going to try and show one slide. Again, just very, big thank you to everyone that's presented so far. Now we're going to go into a discussion, a kind of an open, I guess, discussion. Maybe we're going to preserve the next 10 minutes to go through questions that have shown up online. And then then we'll kind of open it up. But before, I just wanted to show, if I can figure it out, one slide that is supposed to, let me see, which one am I showing? Sorry, bear with me, y'all. Show screen, which one am I showing? All right, there we go. I just wanted to kind of give like a one sentence summary, not bringing down everything that everybody said to one sentence, but I think they're just helpful summaries to remind people of everything that we've seen so far. All right, so Peter started speaking and was discussing how HEBs, right, are observationally and conceptually distinct from classic turbidites, and there's a lot of work that we can do on that. We then went to Meg, who discussed the importance of really, again, integrating the concepts of dynamic process evolution that is absolutely critical to understanding bed form variation and starting to think about positioning where we are, right? We then went to South Africa with Yvonne, who showed us and started discussing the importance of really testing our hypotheses on the distribution and occurrence of hybrid event beds and what that actually means for interpreting the depositional environment where we are. Anders brought us over to Argentina and further discussed the importance of understanding these systems from a process perspective, because seafloor topography adds complexity into that mix. Right. Aurelia then started asking questions on what is different in terms of the occurrence of hybrid event beds and the distribution in intraslope lobes, and is understanding the variability that we see between intraslope lobes and more classic unconfined basin floor fan. Will that help us better understand where we are? Todd then discussed, the need to understand whether H3 divisions reflect multiple flows and flow regimes, and this is very important for understanding, again, the processes, but also the evolution of these systems. Jill and Stan started talking about how silt enrichment within HEBs and how they're different than turbidites affects volumes and definitely flow in these systems that we're looking at all over the world, and starting to ask that question and kind of trying to empower the research community to discuss, well, what is there differential distribution of different types of hybrid event beds in unconfined versus more unconfined system, right? Jog asked the important question, what is the matrix? We all need to consider that, right? We need to understand the impact that matrix and facies variation has at different scales from bed to bed sets. What does that mean for really understanding the processes and having much better spatial predictions? Marco kind of brought it, I think Marco did a good job of bringing things together and, empowering the research that's going out there, saying that these large scale depositional models and differences between turbidites and hybrid event beds does have a big implication on the industry. However, while all this work, it's very great that all this work is going on from multiple perspectives, and we need to continue this hybrid event bed research and develop more predictive models by really integrating everything that's actually been shown today, going from outcrop and subsurface observations, process understanding, and understanding how to interpret the depositional environment and positioning that we're in within these systems. So that was kind of, a blast of summary of the presentations that we just saw. What I'll open up now is bring up the questions, if I can figure that out again. Oh God, they disappeared. Here we go. They don't want to expand. There we go. Anyways, all right, here we go. So one of the questions I'm trying to bring back to where we were.
Excuse me, Fabien, can you start from the bottom up?
Yes. Wait, like the last question that was just asked?
Yes.
All right. Okay. Yep. There we go. Let's change it around. Okay. So this is a question from Pangfei Hu at I think you're still at School of Mines, right? It's a question for Jog regarding the flow separation. Is there any idea of when and where it is more likely to happen? For example, how far will it travel before? How far will the flow travel before the separation, or what controls that separation?
If I understood the question correctly, and if by flow separation what he means is how it changes the turbulent kinetic energy. As I mentioned earlier in the presentation, it has to do with the introduction of a lot of sediment. In this case, you're introducing a lot of fine-grained silt and mud particles, and so that greatly reduces the turbulent kinetic energy. And as far as how it starts to deposit, or based on the two examples that I have looked at, which is the Windermere, in which the flow is still booming through and the sedimentation is happening along the margins, these things are able to deposit this organized set of facies along the margins. And in the downflow terminus, where the flow has exhausted its turbulent kinetic energy, and it just has to deposit whatever sediment. In this case, it's a lot more mud enriched, so it starts to deposit in the same manner as it deposited along the margins. Yeah.
Excellent. Okay, here's another question, a provocative question. Okay, I haven't read it yet though. Why do you persist in claiming hybrid event beds sometimes are nothing more than, or hybrid event beds, sometimes they are nothing more than beds that register only local modification of the rheological characters of the turbidity current? This is from Salvatore Milli. This is an interesting point. In my opinion, terms should be abandoned, as such deposits should only be described as a different type of facies of turbidity current. I guess that's a question that's really, open for everyone. That was another question that actually, I guess, popped up throughout there is, to what extent are all these variations, I guess, not just subtle differences from turbidites, but actually systematic changes in flow character that have systematic implications. I guess who wants to take a stab at that first?
Well, let me chip in. I think it's really important to recognize that there are radically different flow processes at work during a single event. And so, a hybrid event bed doesn't actually imply the process, so it leaves that open. Yeah, so I think it is important, and to me, it's hard to accommodate it within the turbidity current or turbidite. Yeah. But others chip in.
I mean, I think that question goes to where we started with this research question kind of like 20 years ago, is where is the matrix or the debrite, the meat of the sandwich, where is it coming from? Is it locally derived? Is it long distance derived? Is it directly genetically linked to the flow processes involved, or is it just an interfingering of two different flow processes? And I think a lot of the early work concerned itself around, could this being derived from localized slopes? And certainly I recall in the Arnott basin, we looked long and hard at the interformational class that were in the debritic section to see if they were blue marl laden, blue marl being the main slope substrate. And for the most part, we found that they were not. We found that they were eroding previously deposited slope material, which spoke to more, I mean, it could still possibly be locally slope derived, but it seemed to speak more to longitudinal processes rather than local processes. And then people like Peter et al. Started really going to town and got into the full process sedimentology of it. But I think that question goes right back to the start of hybrid event beds. It's probably not an answer, it's more of a comment.
And I think that's a really good comment, and and it's a good question and a good comment, and it kind of does link back to, honestly, it shows the importance of all the talks and work that was presented today, and kind of brings back to the question that Marco, or the point Marco is making at the end, that we need to synthesize and organize the systematic differences that we really see in these deposits from an observational and process-based understanding, and really start, building those much more integrated depositional concepts and predictive models that kind of allow us to, ask those, or make better predictions in the industry space. But I think the process that, the scientific community is going through right now, trying to synthesize the depth of knowledge that we have on these deposits right now, is going to start bringing together, and I think creating a much more robust understanding of just how different these systems are and how important it is to recognize those. So excellent. Okay, so now I'm going to go. Oh, go ahead.
No, I was just going to say, before you move on, there's nothing local about these. They're incredibly extensive and they dominate large volumes of the stratigraphy. So I think we certainly in industry would have been crippled without Peter Horton fundamentally, but Peter Horton and all the associated research that has been done. I think it's enormously helpful to be able to distinguish genuine turbulent flow deposits from all the other transitional and cohesive and, well, what I so lovingly call dumpites, because there's deposits that freeze large volumes over large areas as far as I can see. And those processes are so important and they're not local.
Good point.
The panel agrees. Everybody nodded.
All right, here's another question from Lawrence Amy. Do we see the transition from debrites to turbidites to hybrid event beds? Oh, actually, sorry, that was answering a question up there. So I think let's discuss that right after. Here is another question. I guess this was for Jill and Stan. What's the lithic composition that you guys saw in the GOM Paleogene? Any volcanics? What's the nature of the carbon terrestrial, the carbon that you guys are seeing?
And actually, I think this also speaks to the fact this is not a local process. So number one, the Paleocene is lithic rich in the terms of metamorphic fragment content, and the Eocene in the Gulf of Mexico does indeed have volcanic component, a very large volcanic component, and it's a degradational one in terms of reservoir. And we actually see fragments of glass, and extraordinarily those little pieces, incredibly fragile little points on pumices and all sorts, are actually preserved in these flows. So there's definitely something going on that protects quite fragile components in the flow. And the other question is related. The carbon is definitely coming from plants. In fact, palynology is a really important aspect of correlation in the Gulf of Mexico, because we're in a time when the biostratigraphy can actually be quite confusing. But the carbon content is kerogen, yes. There are bitumens, but they are not related to the original turbidity current process. They're actually often in dikes and so on within the reservoirs. They're related to a different process of migration. Does that answer your question, Wayne? Maybe.
I think, oh yeah, I was gonna say I was waiting for it, but I guess so. Yeah, sorry, I forgot to mention the name on that one too. All right, here's another question right here for Jog again. If I understand you correctly, you suggest that the bipartite. This is from Elizabeth Steele, by the way. If I understand you correctly, you suggest that the bipartite divisions are a result of settling of coarser particles and upward flux of fluid and fine particles. I'm wondering what you think causes the sharp contrast in bipartite divisions rather than a gradational change, if this is the case. Interesting point.
Right. So, from walking out these individual lithofacies, transitions that I've seen multiple times, what happens with this interface is that it goes from very matrix poor bed, which are generally thick bedded, to something that is medium to thick bedded matrix intermediate sandstone. But the transition to a bipartite bed is actually a gradual transition where the interface, the upper muddy part and the lower sandy part, at the beginning, the lower sandy part is much thicker and the upper muddy part is, you know, in terms of few centimeters thick. And so, you know, the thing that makes this color change happen is that there is a certain threshold of mud concentration that has to be elutriated and has to have enough abundance that it starts to create this plug-like feature. And so from all the point counting work that I have done, you know, it starts to create this distinct interface at about, I would say, 40% or greater than 40%. And that's when it really pops out, the color change between the upper mud-rich part and the lower more sandy part. Did I answer that question, or?
Fabien?
Yeah, I think what kind that is answered.
Okay.
Yeah, I think that was answered. Yeah, sorry,
Right.
forgot to unmute myself there.
Okay, so I think Fabien has to disappear off now because he's got other work commitments. So from this point on, I think Lillian is going to be asking questions to our panel.
Yeah, so we have a large list of questions, and I'm going to start one question for Dodd. Dr. Dodd mentioned the probability of multiple flow units for interpretation of H3a and H3b. And Dr. Arif Hussain stressed on the vertical stratification of the linked-debrite flow. Which one is more likely to occur?
Probabilities, I've not got that far yet with the work that I'm doing. There's a straight answer for it. I guess I'm just trying to, I've got a set of relationships in nice core data that I'm just trying to explain by putting in these sharp boundaries and documenting the geometries. And that's as far as I've got. And there's some geometries that I can see which I can only explain by having separate flow events in them, and that's what I was trying to get across by talking about the H3 relationships and the internal divisions of H3. Is it? It's at an early stage basically, but yeah,
Okay.
Sorry,
no, it's fine. It's you know, this is one of the beauty of when we invite all of you. We knew that we have a wide range of expertise. Some people are in the middle stage of their projects, and other people are more advanced in working with hybrid event beds. Now, one of the questions from Marek went for is, did you see shear features at the interface? Did you see shear-like features at the boundary interface within the bipartite bed? So I imagine that is for Jad, the question.
Simple answer is no, we don't. And the interpretation that we went with was of, you know, if it's shearing, you know, it's negligibly sheared suspension. And usually when we observe these bipartite facies, they are usually a very knife sharp planar contact between the two interface. Yeah.
Okay. So another question is from Steve Brown, and is how do the hybrid event beds differ from the Bouma sequence?
That's one for Peter.
Go, Peter.
That one's for me, is it?
Yes.
Yeah.
Yeah.
Sorry to put you on the spot, but
Yeah, well, I guess that sort of model bed we tried to put together with the 5 divisions in it was an attempt to illustrate that it is different, that you know, rather than progressing from a structural sand up into lamination, you progress up into often banding and perhaps development of, you know, transitional bed forms are driving that. And then into what looks like a debris flow, and you know, often has a muddy matrix and often coarser grains in it. So, you know, which is kind of not what you would normally see in a Bouma sequence, with it tending to grade and fine upwards. But then capped with a laminated or rippled top to it, a bit like a Bouma unit, but not always like that. Like I showed you an example where the uppermost unit had banding again in it, and then was becoming more cohesive again. So yeah, so I think it's the fact where we have a lot of clay, and as Marco mentioned, you know, in a Bouma sequence, a lot of the clay ends up in the TE division, whereas, you know, there's a lot of clay lurking lower in the bed in many of these hybrid event beds.
Okay, thank you, Peter. So I'm going to ask Aurelia, maybe do you plan to access if the length of the scales over which you see the variations are significantly from unconfined? Sorry, this question was, Emma, could you ask the question? I got it in a different chat, so I'm kind of like a multitasking here.
I don't think that the audience can unmute themselves to ask verbally.
Oh, okay.
I believe.
They can.
Oh, they can. I'm sorry.
Yes, sorry, Emma.
Yeah, I forgot to unmute myself. I was talking to myself.
Yes.
So yeah, Aurelia, do you plan to assess if the length scales over which you see the variations are significantly different for more unconfined BFFs?
Yeah, because the variation can be seen across several kilometers. So let's say from 5 to 8 kilometers, you can see this lateral facies transition. So yeah, it's a shorter scale than what we used to look in unconfined systems.
Cool, thank you.
Yes, so this is a comment from Bill. In my mind, the big question is whether these various named features are formed by one or multiple processes. It is several is intriguing, and when considering the gross characteristic of all of these strata, they are seemingly very similar. Another question, this is a little bit more broad, from Nissar Ahmed, and is, do we have any basin having mud-rich, mixed, and sand-rich deep marine deposits in one single basin? I don't know if any one of you would like to answer the question or mention as an example the basin that you guys have been working on.
For my part, in the Nauken Basin, the Los Moches records vertical evolution from matrix-rich systems that are matrix-rich because the source is rich into immature minerals, like a lot of volcanic rocks that get eroded and also contribute to bringing more mud and matrix to the system, to the final sandstone. And then these evolve vertically, stratigraphically into cleaner sands, and you get more, you get less matrix in the system. Basically, the sands become clean and you don't have any more hybrid event beds.
Okay, thank you, Aurelia. One question for Megan is, how large are the current ripples you call large? They look to me small scale features, and that is Marek went for who made the question.
Okay, thanks, Marek. Yeah, so I suppose we called them large current ripples in comparison to sort of sandy current ripples. So they are, yeah, small scale features. So our sandy current ripples, which are kind of, you know, sort of the classic current ripples were about 11 millimeters high, and about sort of 100 millimeters long. And then our large current ripples were significantly bigger than those sandy current ripples. So they were about 20 to 30 millimeters high, and then about 200 to 400 millimeters long. So it's kind of, we call them large current ripples in reference to sandy current ripples.
Okay, thank you. So Elizabeth still also have another question, I imagine for Jack, and is here somewhat is a vague question, but there is a fundamental difference between the bipartite beds and the hybrid event beds, or is this just a different terminology and a slightly different process interpretation?
Oh, that's a really loaded one. I don't know how to answer this because, you know, this is all based on the field observations that I've made and the interpretation that is based on all the, you know, point counting work, textural analysis work that we have done. And yeah, the process that you know, closely resembled what results we got, you know, we have used that. And so, yeah, like, I don't know, what does Peter think?
Yeah, I think related maybe, but there is a very wide family of these sorts of event bed. I think, you know, what's interesting in the ones you describe is the small length scale. And yeah, I was interested in the chloridome. You know, if you think that's proximal to distal, that's pretty interesting. It was 500 or 600 meters, is that right?
Yep.
Yeah, I mean, you can understand the kind of the short lateral scale in the Windermere. But yeah, that was interesting how short scale they are in a longitudinal sense there. But you know, I think there are definite parallels. You know, when I showed that image of all the different places we see these, I included the evulsion sort of setting that you and the others are thinking of. But yeah.
Okay, thank you, Peter. Yes,
I
sorry.
can maybe try elaborate a bit more about that, because maybe bipartite can be a terminology that can be applied to different things. For example, bipartite flows to me is a category in which the hybrid beds are inside. Like bipartite flows and deposits can be beds composed by a part of the flow which is very dense and a part that is more turbulent. And hybrid bed are definitely, at least some of them, part of this category, because they have a very dense head, and then they have this interaction with the substrate, and then they form they change their rheology in the head. So I feel that some hybrid bed are bipartite, are made by bipartite flows that got an accident during their flow path.
Mm-hmm.
Yes.
I think, sorry, just a quick comment. The reason why we, you know, almost all of the names that we have given are all based on what we observe, you know, in the outcrop scale, you know, what it looks like. The process interpretation is not something that that we have used to name these bed types. So a bipartite bed, yeah, just the fact that they have two parts to it, yeah, that's the whole point of calling it a bipartite bed. Yeah.
Okay, so the next question is from Lawrence Amy, and is there was some discussion about confinement and non-confinement system, and I imagine that question is for Jill and Stan, and he is asking, is the confinement a key process, I imagine, in the system, or is the grain size?
I would consider that the confinement is more of the key component than the grain size itself. I mean, I think most process sedimentologists know that if you have a range of grain sizes available, the coarse fraction will tell you just how much confinement and restriction of flow that you had, flow velocities, etc. So I think really in this context, seeing coarse class is is telling us something about velocities and confinement, but it's the confinement itself that is the controlling factor, I would say. And I think Jill was speaking to this point, and I should let her speak. But
that's beautifully said, Stan. Because even within the one system, we see confined parts, and they are much coarser, and they have very different HEBs.
Yeah, and I think
Andy Pullum's here. He might have a comment on that. But yeah, I mean, obviously there's shifts, and you do have unconfined coarse grain systems. But again, in my experience, the HEBs are different. Again.
Sorry, Jill.
No, carry on.
I was just going to say, I think one of the things that Jill and I consider is that if the system is sufficiently confined that you're bringing high velocity flows in close proximity to confining slopes, that's when you really have good opportunities for generating the Hortonian type of hybrid event bed. And that can apply in both the lateral sense, but also, you know, the initiation phase in a basin as well.
And also to Marco's point, you just have the confinement, I think, also changes the way that the flows interact with their base. Mm-hmm. And in confined basins, I think you get more of that delamination, the pressure buildup on the substrate as they pound down these quite narrow, structurally confined troughs, can be absolutely intense, I suspect, because they're forced into one place. They can't, they keep pounding on the same substrate.
Spatulation.
They can't spread. Ooh, is that a good term?
It's from Julian Clark.
So we have we have so many questions. One of the questions is from Wayne Camp. He left, but it's an interesting question, and I think other people may be going to ask. And it's about some people talk. You know, it's like is the matrix detrital or autogenic clays? When we are
yeah, I mean, in examples we look at, I guess the matrix is detrital. In some cases recrystallized, like the Ross clays are recrystallized. They've been quite hot, but yeah, detrital clay is the key thing in there.
Mm-hmm. Yes. So one of the questions for I think we have so many. I think this one was for, well, we are this. I'm not sure if we actually, it was another question. Is Elizabeth have another comment? Thanks for the clarification, and I imagine that is for Jack. Sorry to ask a loaded question. It makes sense, and the intention is to keep the process interpretation separate. Have you just been wondering about the correlation between the H1 and the bottom part of the bipartite bed and H3 and the top part? This is an additional question, just shimming in. Thanks.
Right.
Yeah, so one of the Shant asked Dr. Fonesu, you mentioned the difference between delamination process and turbulence erosion. In what condition will delamination process happen?
Yeah, my impression is that delamination will happen more when we have a very dense flow. Usually is happening in the kind of basin like this Stan Gillian talk about, which is more confinement, also more coarse grain, and the flow is less efficient. Otherwise, turbulent erosion would happen more when the flow are more efficient and there is turbulence. You need turbulence to excavate those scours. But also, I feel there is a control from the substrate. Like if you have a very stiff substrate, something hard, maybe just a flow that will impact, that will be able to detach pieces of substrate and carry on it. Otherwise, if maybe the substrate is more soft, everything break up very quickly and will form something more rounded, and so also the material will affect differently the flow. And this will make big difference in terms of deposit down deep. And I think there can be three types. Like the first would be conventional turbidite. Conventional turbidite can erode a lot, but in that case, the mud will help the flow to do elutriation to be efficient. Otherwise, in every bed, they can otherwise stop the flow that will slow down and force the big class or the more argillaceous type to deposit. That's my view on the topic.
Okay, thank you very much, Marco. On behalf of the Deepwater Research Group, Fabien, unfortunately, he has to leave. Emma is here and also here. We're going to wrap up the session today. This has been extremely a great journey for us because we discuss and envision which topic we should start working and start putting people together in one place and start, knowing what exactly is iron event beds, what are the processes involved, where are they forming. So there were so many questions when we got together a long time ago in April. For us, it's a dream come true, and all of you decide to join us in the meeting. So we really are happy that you were able to participate. This is for the panelists and for the special guests. We also want to start, moving this ahead, and many of the questions that we were not able to ask right now, we're going to sort it out, and maybe we are going to send it to you directly. And I think this discussion is going to continue. And the beauty is that I want the people start, from the industry, from the academia, start seeing what you guys have done until now, and start trying to see where are, it's like maybe in a few years we can get together again and we can start seeing if we have converged in a specifically for the processes, then is if we are exactly in the same page or we still have a variety of views. But thank you so much for attending this. All of the people who are 84 attendees who are there still, I'm happy that you guys bear with us. And well, any questions, you can send it to us into the SCPN Gmail, Deepwater Gmail account. And you can follow us in Twitter also. Or maybe some of you already have seen our Twitter account. If you tag us and if you are working in Deepwater, we are going to follow you too, because we want to keep going and we want to maintain a relationship with the whole Deepwater community. And if you have questions, if you have ideas about next meeting, please just email us, and we are going to try to make it come true, because I have to say that when Emma, Fabien, and I in April during the quarantine were talking about what are we going to do this year? We thought that it was going to be impossible, but no, we were able to do it. And thank you so much for staying here. Okay, so I hope to see you in another time, in another conference.
Well done.
Yes.
Good job, guys. Good job.
Thank you
Nice.
so much. You were all wonderful.